Okay, so we got question 8b here. It's not really a follow-on from A, where A was asking about derivatives, but we asked here about this here. Now, of course, in any of these questions, notation's quite important to understand. What is that thing? Well, hopefully you have a sense that it's the inverse. Now, there's clearly going to be a lot of algebra here because it wants in a particular form. So we might find something and then have to work with it algebraically. Now, the function I've put here for reference because it's in part A. And maybe just one other thing is, of course, the inverse, we've got some concepts embedded there that, you know, what's X is Y is X types idea. We might think of it also that it's a reflection about the line Y equals X. So if you knew the function looked like this, then the inverse looks like that. And conversely, the inverse of the inverse gets you back to the function. Okay? And the two functions will intersect on that line. Okay, but I don't think all of that's needed too much here, but worth thinking about when it comes to other questions. Also because if you've got a hyperbola, of course, you can just kind of swap the x and y asymptotes because, well, that's how an inverse works, right? Okay, so but anyway, let's have a look at this one. We know that f of x equals 2 minus 3 over 4x minus p. P is just some sort of constant, so we'll just treat it as a constant. Now, this f of x, of course, is y. So when we do our inverse, we might just say, well, let's just do this and say x equals to find the inverse, right? It's not if not the inverse equals that. That would be if y were the subject of the formula after this manipulation. And let's just dive in, I guess. So we want p over a. So I'm just going to run with some ideas and see where it gets us and go from there. So we might go, okay, well, I'm going to subtract 2 from both sides. And then I've got minus 3 over 4y minus p. Okay, great stuff. I'm kind of getting closer there. Well, we need to multiply by this denominator. You may have done that in the previous step. And there's this pesky minus over here. So we can multiply everything by minus 4y minus p, and that will leave the right hand side just as 3, and what we do to one side we do to the other. All those lovely equation ideas come out. So we can say this is going to be, I'm just going to write it here as x minus 2, and we're multiplying it by 4y minus p. Of course, there are other sneaky things we could do there as well. Okay, so you multiply these things out, and eventually we should hopefully group all the y terms. I'm going kind of step by step here. So I've got x times 4y is 4xy. I've got x times minus p is minus, I know that minus is over here, so I kind of might change my mind. Let's put the minus over there rather, make our lives easier. Okay, so we got 4xy, we've got minus xp, then we've got minus 8y, and then we got plus 2p equals minus 3, where all we're doing is we're just distributing our binomial times a binomial. Okay, so nothing's coming to light yet except, well, here are 2 terms with y in them, so I almost want to factorize out that y already, but let me hold my horses just a little bit here and say we've got that equals, doesn't really matter what order we write things in here, xp minus 2p minus 3. Now, my eyes are darting up to see what our final form is already, to see can we get it in that form sooner rather than later. And that's where we'll maybe come back to see if we're adding in extra steps or could be a little bit cleverer here. So this is kind of just step by step at the moment to go, well, we can pull out this and we got 4x minus 8y. Oh, that's not right. Minus 8. Factorization going wonky here already. xp minus 2p minus 3. And then we've got y equals now this big fraction. Now this is where, of course, things are going to be interesting, where I'm just going to write it out as one big fraction and then see maybe if we could do that a bit quicker. Great straight line there, isn't it? 4x minus 8. Now we can see in our final form that 4x minus 8 is looking promising for the 4x minus 8, but this p should not be over 4x minus 8. So this is where the algebra could get a little bit more interesting to say, well, we need to split this fraction up, right? So the first term over here, I'm looking over here, the first term over here, there are p's in it, and the second term, there are no p's. In other words, let's try and factorize out and get some p's in the mix over here. So let's have a look there. So I've got p x minus 2, right? Out of those first terms, minus 3. Now, if you look at, there should be a way, can I just hold this? Does it make us, oh, look at that. There we go. Learning new tricks, or old tricks, should I say. So we've got that. Now in the denominator, perhaps you can see it already. Can you see it? Can you see what I'm about to do? What's going to help so nicely to get this p sorted out? Yes, of course it is. There's a nice common factor, which means there's a 4x minus 2, which means when you rearrange this, remember this is the is the inverse, that when we split this into two fractions, as long as x isn't equal to 2, we've got p over 4 minus 3 over, almost forgot my 4 there, 4x minus 2. Now, it did say that we must have it in this particular form, cx minus d, in which case this 4, we should multiply in 4x minus 8, just so it's in the form that they wanted. Okay, hopefully that was helpful, perhaps a bit long-winded, but we'll get there, right?